Hello, welcome. I'm happy to have you here, and I'm happy to prep with you for the Chapter 3 retake. Or in the event if you're taking it for this is your first attempt, I wish you well, and I'm happy to prep with you to get you primed for the test. Okay, so um, for the Chapter 3 retake, or for your initial attempt, we're going to be studying and prepping using the study guide that we used in class. So we're first going to be reviewing Chapter 3, Section 1, and Section 2. And we're going to be talking about the four angle relationships that were introduced in Section 1 and Section 2. So those four angle relationships, we talked about alternate exterior angles, we talked about alternate interior angles, corresponding angles, and we talked about same-side interior angles that are also known as corresponding, as consecutive interior angles. So those angle relationships, they have special properties when you have two coplanar lines that are parallel. Before we get into the special angle relationships that are part of parallel lines, we have to know what a transversal is and how to identify our two coplanar lines. So a transversal is just the line that intersects the two other coplanar lines. So we call that a transversal. And in your textbook, they define the transversal as a line that intersects two coplanar lines at two different points. Okay, and in doing so, they form eight angles. So in doing so, they form 8 angles. Okay, so looking up here and identifying the transversal, it's kind of intuitive that the transversal would be the line named T, but if we didn't associate that, and we could find that the only line that intersects the other two lines twice is this line right here. So in the context of when we have two parallel coplanar lines, it's easy to identify the transversal. It's easy to identify the transversal because it is the only line that will intersect the two other lines, that will intersect other lines twice. So we know that T is a transversal here. We know that M and N are the two coplanar lines, and we say coplanar because they're on the same plane. So sometimes we see this parallelogram or rectangular-ish type shape that boxes our lines, and then you see arrows that are on the outside of them moving in opposite directions to show that this plane, this surface that these lines are on, move infinitely in different directions forever. So it's kind of like this. We have this graph right here, our x and y graph, and our x-axis and y-axis. So our y-axis is moving infinitely in opposite directions. Our x-axis, for positive and negative, is moving in opposite directions forever. So it's as if our idea of this graph is that it moves infinitely in all directions forever. So it's the idea that what this brings. Obviously it doesn't move on forever, and that the paper stops after 8.5 inches, but it's a thought, it's the idea. Okay, so all right, so we know that this is our transversal. We identify our parallel lines by these arrows that are through our two coplanar lines to show that they're parallel. Okay, so we have 8 angles that are formed from the transversal. And now we have to talk about our angle relationships. So we're first going to be talking about corresponding. So corresponding angles when you have two coplanar lines that are parallel. Okay, so corresponding angles when you have two coplanar lines that are parallel. How do we identify corresponding angles? So they're on the same side of the transversal. So that's one criteria, or one rec. they have to be on the same side of transversal. So 2, 4, 6, and 8 are on the same side of the transversal, and 1, 3, 5, and 7 are on the same side of the transversal. And you have to skip an angle. So these corresponding angles are congruent with parallel coplanar lines. Okay, so we have parallel coplanar lines here. So these corresponding angle pairs, these two angles, whatever they are, they're going to be congruent. So if I have, and I'm going to circle, so I'm on the same side of the transversal. 2, 4, 6, and 8 are on the same side of the transversal. So 2 is on one side of the transversal, and I'm going to circle it, and I skip one angle, 4, and I lie on the other angle. So for our corresponding angles, we can say that angle 2 is congruent to angle 6. So what does that mean? If angle 2, for instance, was, and it looks like it would be about, I don't know, an 80-degree angle. So if angle 2 was 80 degrees, we could say that angle 6, because these are corresponding angles, angle 6 will also be 80 degrees. If we said that, so 4 is on one side of the transversal, I'm going to circle it in green. And so I'm on the same side of the transversal, a little bit below it. And I skip one angle, and I end up at 8. So angle 4 is going to be congruent to angle 6. Angle 4 is going to be congruent to angle 8. I'm sorry. So 2 and 6 are going to be corresponding angles, and 4 and 8 are going to be corresponding angles. And if we know that what angle 4 is, we know what angle 8 is going to be, because, like I said, we have two coplanar lines that are parallel. What about the other side? Angle 1. What is the corresponding angle to angle 1? Well, angle 1, 3, 5, and 7 are on the same side of the transversal. Okay, so we're on the same side of the transversal, and we have to skip an angle to find the other one. So angle 1 is going to be corresponding to angle 5. So we could say that angle 1 is corresponding to angle 5. And we can also say that angle 3 is going to be corresponding to angle 7. Okay. So that's how we can identify corresponding angles. Okay, so just give me a second to receive. Okay, so I have 1, 2, 3, 4, 5, 6, 7, and I have 8. Okay. Okay, so now we're going to be talking about alternate exterior angles. So what are the defining characteristics or points of alternate exterior angles? So they are on both angles on the exterior of the coplanar lines, and they alternate. It's probably better to say that, well, we can say it. They alternate across the transversal. So the angles, they alternate across the transversal. And last, the angles, they hug different coplanar lines. Okay. Okay, so first, the exterior. What is the exterior of your coplanar lines? So we have to identify that. Okay, so in order to do that, we have to, when we say the interior, we're saying the inside. We're saying the inside of our coplanar lines. So the interior is going to be inside what is shaded blue. So I'm going to say that that is I'm going to say that that is going to be the interior. I'm going to say interior. And then on the outside of the coplanar lines, so on the outside of these, is going to be the exterior. Just going to shade it in pink. So I have this is going to be the exterior. The exterior. Okay. So how do we define alternate exterior angles? Okay, so both angles are on the exterior of coplanar lines. So I have angle 1 and 2 and 7 and 8 on the exterior of my two coplanar lines. They're on the outside, moving away from the lines. Okay, so and they alternate across the transversal. So 1, if I move across the transversal, it could be 1 and 2, 7 and 8. But wait, the angles hug different coplanar lines as well. Okay, so they're both angles on the exterior of the coplanar lines. They alternate across the transversal, and the angles hug different coplanar lines. Okay, so I'm on the exterior. 1, 2, 7, and 8 are on the exterior. They hug different coplanar lines. So 1 and 2 hug the line M. 7 and 8 hug the line N. But they also move across the transversal. They alternate across. Okay, so 1 is going to be the alternate exterior angle of 8 because they hug different coplanar lines. They move across the transversal, and their exterior angles. We can't say that 1 and 2 are alternate exterior angles because they both hug the same coplanar line M. We can't say that 7 and 8 because they hug the same coplanar line N. We can't say that 1 and 7 are the same are alternate exterior angles because they alternate across the transversal and move across. So angle 1 is going to be the alternate exterior angle of 8. Angle 2 is going to be the alternate exterior angle of 7. Okay, so once again, these angle relationships, when you have parallel lines, they're going to be equal in angle measure. Whatever angle 2 is going to be equal to 7. Angle 1 is going to be equal to angle 8. Okay? Alternate interior angles. Okay, so they're interior angles. What defines alternate interior angles? So right here for corresponding, hold on a second, for corresponding we could say angle 1 and angle 5, angle 3 and angle 7. We can say angle 2 and angle 6, and angle 4 and angle 8. Okay. For alternate, and these angles, whatever their angle measures are going to be, they're going to be equal because we have parallel lines. Okay, and then we have for alternate exterior angles, we have angle 1 and angle 8. We have angle 2 and angle 7. Okay, for our list. Defining characteristics or points of alternate interior angles. So both angles are on the interior of our coplanar lines. Okay, they both alternate across the transversal. Okay, and it's very useful to think. The names really give clues. Alternate. Whenever you see alternate in the name of the angle relationship, Whenever they say you hear alternate, we're saying where the angles move across the transversal from each other. The pair moves across. Whenever you hear interior in the name of the angle, it means that the angle pair, both of those angles, have to be interior. Okay, and then they hug different coplanar lines. Okay. They hug different coplanar lines. So those three, they need to meet those three rects. So looking here, they both have to be interior. So what are in our interior of our figure? 3, 4, 5, and 6 are interior angles, right? Okay, so they have to move across from each other, across a transversal. They're alternating across. So it could be 3 and 4 alternate across, and 5 and 6 alternate across. But wait, both of those angles have to hug different coplanar lines. So 5 and 6, although they are both interior and they both move across the transversal, they alternate across the transversal. They both hug the same coplanar line N. But what about 5 and 4? They alternate across the transversal. They're both interior, and they hug different coplanar lines. So angle 5 hugs the coplanar line N. Angle 4 hugs the coplanar line M. So we can say that the alternate interior angles, what meets meet those rects, it's going to be 5 and 4 and 3 and 6. So I'm going to write angle 5 and angle 4 and angle 3 and angle 6. And once again, alternate interior angles, the angle pairs with parallel lines that are coplanar, with coplanar or parallel lines are going to be congruent, so the angle measures are going to be the same. The defining characteristics or points of same-side interior angles. So they have to be on the same side of the transversal, and we have they have to both be interior angles. Okay, so looking at our figures, they have to both be interior angles. We have 3, 4, 5, and 6 that are interior, and they have to be on the same side of the transversal. So 4 and 6 are on the same side of the transversal, and then 5 and 3 are on the same side of the transversal. They're above T. They're moving above T. And then 4 and 6 are below T. So we could say 4 and 6 are same-side interior angles. Another name for same-side interior angles, like I said, are consecutive interior angles. Make sure you know that, because you will see it. So we have angle 3 plus angle 5 is going to equal 180 degrees. We have angle 4 plus angle 6 will equal 180 degrees. We need to know that same-side interior angles are a little bit different than the other three angle pairs that we've been introduced, corresponding angles, alternate exterior angles, and alternate interior angles, that are congruent with their angle pairs. Same-side interior angles, they're going to add up to 180. So 4 and 6 will add to 180, and 3 and 5 will add to 180. Okay, so we know that the coplanar lines, they separate the interior from the exterior. We know that corresponding angles, we learned to identify them, the different criteria that they have to meet for to qualify as corresponding angles, alternate exterior angles, alternate interior angles, and consecutive interior angles. We know that of the 4 angle pairs that we've been introduced today, or within this chapter, the first 3 corresponding alternate exterior and alternate interior angles, the pairs are congruent. So the angles, the pair of angles will be equal each other in angle measure. Now just as a rule of thumb, this only works when our coplanar lines are parallel. If our coplanar lines were not parallel, these special angle relationships would not hold. Now, we would still be able to identify them as corresponding alternate exterior, alternate interior angles, or consecutive interior angles. But we would not be able to say that, like for the corresponding alternate exterior, alternate interior angles, that the angle relationships are the same, that the degree measures are the same, that the special properties hold of congruence or adding to 180. This only holds when your coplanar lines are parallel. I know I've said that several times throughout this video, but I can't stress it enough, and I'm repeating myself just to hold emphasis because it is very important. Okay, so now we're going to move on to identifying, so we're going to talk about this. So here, on the front of our study guide, we have to list the congruent pairs of alternate exterior angles. Okay, so if you want to pause the video and move back, you can write those down, the recs that they have to meet to be qualified as alternate exterior angles. But if not, we can just go through it. So the pairs of alternate exterior angles. So to qualify as alternate interior angles, we first have to look at our coplanar lines. We see that they're parallel, so we know that our special angle relationships are going to hold. So we have our two parallel lines, and I'm going to shade the inside blue, and on the outside, the exterior of our coplanar lines, I'm going to shade in pink. So I have, in the blue, I have interior, and on the pink, on the outside, moving away from our coplanar lines, is called the exterior. Okay, so to qualify as alternate exterior angles, okay, so they're moving across a transversal, they're hugging different coplanar lines, and they're both exterior angles. So we can say that angle 1 is going to be congruent to angle 7, and we can also say that angle 1 and angle 7 are alternate exterior angles. We can also say that angle 2 is congruent to angle 8. Say that angle 2 and angle 8 are alternate exterior angles. We can say that because it meets the three recs that we talked about. They hug, each of the angles, they hug different coplanar lines. Our coplanar lines are M and N, and they alternate, they move across the transversal, and they're on the exterior of the exterior region of they're outside of they're exterior of our coplanar lines, angles that are exterior. Okay, so the pairs of corresponding angles, we can say that angle 2 is going to be equal or congruent to angle 6. We can say that angle 3 is going to be congruent to angle 7. We can say that angle 1 is going to be congruent to angle 5. Angle 4 is going to be congruent to angle 8. Okay, so we can say all these angle pairs that are congruent are going to be corresponding angles because they are on the same side of the transversal. You know, they're either above or below, and they skip an angle. And we can say that these angle pairs are congruent. So whatever the degree measure of these angles, they're going to be the same, and that they qualify as corresponding angles. So 2 and 6 are corresponding, 3 and 7 are corresponding angles. Say that angle 1 and angle 5 are corresponding angles. We can say that angle 4 and angle 8 are corresponding angles. Okay. We're going to move on to listing the congruent pairs of alternate interior angles. Okay, so they're both on the interior of our coplanar lines, and they alternate across the transversal. So that we know within the name, we're moving across the transversal, they're both interior. Kind of like with the alternate exterior, we know that they're alternating across the transversal, and they're both exterior angles. So the name gives us clues from the get-go. So alternate interior angles. So on the inside, moving across 4 and 6. So angle 4 is going to be congruent to angle 6. So what are the what qualifies alternate interior angles? Well, 3 points. Okay, so they have to be interior, they have to be angles that are on the inside of our parallel lines. They have to, both of the angles, they have to hug different coplanar lines. 4 hugs M, 6 hugs N are only 2 coplanar lines. Okay, and they move across a transversal, so we move across this transversal, so we move across diagonal. 4 and 6 and 3 and 5 are going to be alternate interior angles, and angle 5. And I put the congruent symbol because the angle measures are going to be equal, but why? Well, we have parallel lines. And we know that although we can identify these types of angles when our coplanar lines are not parallel, but when we have parallel lines, we can show this congruent symbol to show that their angle measures are going to be the same. Because these angle pairs, they have congruent angle measures when you have parallel lines. Okay, so 4 and 6, angle 3 and angle 5 are alternate interior angles, alternate interior angles. Okay. Consecutive interior angles. So what qualifies consecutive interior, or what's another name for consecutive interior angles? Yes, you got it. Same side interior angles. Right. So same side interior angles, 3 and 6, they're on the same side of the transversal. They're interior on the inside of the coplanar lines. So we have angle 3 and angle 6 are same side interior. What is our second pair? 4 and 5, right? 4 and 5 are same side interior. What is the difference between same side interior and the rest of the angle pairs that we've been introduced? So we've been introduced to alternate exterior angles, corresponding angles, alternate interior angles. But same side interior angles are different because with parallel lines, the other 3 are congruent. Their angle measures are equal. But with same side interior angles, the angles add to how much? You got it, 180 degrees. So angle 3 plus angle 6, angle 4 plus angle 5 equals 180. So just keep that in mind. Say, for another name for consecutive interior angles. Now I know we've been over it, but I can't stress it enough. Same side interior angles, another name. You'll see them as consecutive interior angles, but I find that same side interior angles is easier because we know it's same side. I can kind of clue in and think, oh, the same side of the transversal. They're both angles on the interior. I think consecutive interior is a little bit more confusing, but they're more formally known as consecutive interior angles. So you will see consecutive interior angles in mathematics more than you will see same side interiors. Well, as far as my experience, I can't say for the tally of all math, but anyway. Okay, so we're going to pause this video, and then we're going to move on to the next page. See you soon.